good evening, whatever the case may be. We are back in better than ever, and today we're talking about the cosine function as we're spinning another tune from Dave's Fave, Rock and Roll Part 2, and of course the CD produced by the great Darby Foster. Let's get to it, shall we? All right, so we're just talking about cosine and the graph of the cosine function, and it is just actually a translation of the sine function. As you can see here, here we go. Here is the graph of y equals sine x right here. And if I took sine and I grabbed it and I pulled it over here, it would fall right on top of the graph of the cosine function, which should make perfect sense because the cosine and sine functions in our unit circle all share the same values, but at different, all share the same ordered pairs, or the same values of the ordered pairs, just at different points on the unit circle. Our values are root 3 over 2 plus or minus 1/2 plus or minus root 2 over 2 plus or minus 1 and 0. That's it. That's all we use to graph the unit circle. So for cosine or sine, it's going to be one of these. And with the symmetry of the unit circle, it should be obvious to us that the cosine curve is simply the sine curve translated to the left. And that's going to be pi over 2 units. And that's what we're saying here. Cosine x is equivalent to the sine of x plus pi over 2. In other words, grabbing the sine curve and moving it pi over 2 units to the left. Let me show you what I mean here. So if I quickly graph sine x, and I know we're very familiar with this, bam, there she is. So here's 0, pi over 2, pi, 3 pi over 2, and 2 pi. We're very familiar with it. And our y scale with a max of 1 and a min of negative 1 right there. And now I'm going to graph cosine x. And what you should expect to see, if you can imagine this sine curve moving to the left pi over 2 units, that is what we're going to get for cosine. Bam! There she blows. And just to prove it to you even further, I'm actually going to grab this sine curve and try and move it to the left. Now notice that the equation is changing for it, but let's see if we can get it right on top of there. I'm trying 1.56, 1.56, 1.57. Move it up just a little bit. Oh, not bad. And we can see when I let go, it's right on top of it. I translated it 1.57 units to the left. Now 1.757 is approximately equal to pi over 2, and I'm off just a little bit on the vertical translation. So let's get that back and we'll do it exactly. Let me double click here and we'll translate it. Pi over 2 units to the left, so that's going to be plus pi over 2, as you see me typing. And once I hit enter, it's going to disappear behind the cosine x curve. Bam! There it is. Yes? Right behind it. So let's just keep going back and forth. Sine x, pi over 2 units to the left, same as cosine x. Sine x, pull it left, same as cosine x. Okay? So with that knowledge, it should be fairly easy to graph the cosine curve. Now let's just take a look at the basic cosine curve before we move forward. Cosine at 0 begins at 1, so that's its max. Its min occurs at pi. Cosine of pi is negative 1, and then back at 2 pi, it is 1 again. Okay? That should make sense because the cosine of 0 is 1. The cosine of pi over 2 is 0. The cosine of pi is negative 1. The cosine of 3 pi over 2 is 0. And the cosine of 2 pi is 1. All right, so let's do a couple of graphs and we'll wrap this thing up real quick. General cosine function is the same as sine. It's just a cosine A, B, C, and D clearly have the same effect on the function on the graph of the function as they do for any other function. It's the same thing for all functions. So let's graph these bad boys. We got to graph cosine x and cosine of x minus pi over 3 from negative 2 pi to pi. So I'm going to do it by hand. I always have you guys do it by hand, so I'll do it by hand as best I can. Got my little drawing tool here. Bam. So first I'm going to mark my important critical points here. So here's a 2 pi. So that means pi is about here. And then pi over 2 is here. And 3 pi over 2 is here. That's where I'm going to find my zeros and my ones. Then I'll go about negative 2 pi here. Halfway through is going to be negative pi over 2, and negative 3 pi over 2. Bam. Now I need my y-axis, so this will be my 1. Make it about the same, negative 1. And now for y equals cosine x, I'll do in pink. And let's mark my points. Cosine of 0, I'll put the 0 there, is 1. Bam. Cosine of pi over 2 is 0. Cosine of pi is negative 1. 3 pi over 2, 0. And 2 pi is 1. And so you get a nice smooth curve as best as you can. Ooh, make my point a little larger. There we go. We got a minimum coming back up to 0. A 0, and then, oops, that was awful. And then a nice smooth curve up to cosine of 2 pi being equal to 1. So I got to continue it because my domain is from negative 2 pi to 2 pi. So the pattern remains, and if you think cosine negative pi is going to be negative 1, negative 3 pi over 2 is 0, negative 2 pi is going to be 1 again. And I'm going to go left to right because that is how I roll. Oh my, that's not bad at all. Look at that. So that is y equals cosine x. And now I have to graph y equals cosine of x minus pi over 3, meaning it's a horizontal translation of pi over 3 units. Now, remember the relationship between, or where, I shouldn't say relationship, the location of pi over 3 between 0 and pi over 2. And just a quick reference for our unit circle. Here's 0. Here's pi over 2. Bam. Here's pi over 6. Exactly 1/3 of a rotation up from 0. Oops, pi over 6. And then another third of the way would be pi over 3. So between 0 and pi over 2, pi over 3 is 2/3 of the way to pi over 2. So I can get a good guesstimate here. So I'm going to say this is my pi over 3. Okay, and the translation is to the right since this is negative. So I'm just going to take all my points that I used here and move them to the right, pi over 3 units. Boom, about right here. Got a 0 here, about here. Got a minimum, about here. Then about here. Okay, and so let's just graph that part right here. Go through the 0, come down through the minimum. Oops, I missed it a little bit, but not too bad. Then come up, and it's going to start going like that. Now let's move these points, so that's about right here. 2/3 about here. 2/3 of the way about here. 2/3 of the way about here. Do the same thing. Coming on down, right? And here we go, back up until we hit another maximum. So that's not bad, but I need to come down. Now, at the negative 2 pi, it should be at about the same spot as the right end here. So we try and do that as best we can. And so that would be my y equals cosine of x minus pi over 3. No big whoop. It's no different than graphing a sine function, and except with sine, remember, you would be starting at 0, right? It would go like that. That's a horrible thing. It didn't go up to 1. I'm going to get rid of it. But with cosine, your y value is 1 when starting at 0. All right, I hope you enjoyed that. It was awesome for me. We shall see you next time, and with that, I am out!